All right, for number one, we are asked to find the equation for a quadratic, and they give us the vertex and a point that it passes through. So the first step is we're going to use the vertex form of an equation. So I'm going to change my color here. So we're going to use y equals a times x minus h quantity squared plus k. Now with the vertex, remember the vertex, that's your coordinate h and k. So we're going to set this up to say y equals a times x minus 4 squared. And then we could say plus -5. I'm going to write it as minus 5. Now my goal is to figure out what's this value for a. And that's why they give us this other coordinate. So this other coordinate, remember this is your x and this is your y. So we're going to plug that in for our x and y values here. So we'd have 22 equals a times, 1 minus 4 squared minus 5. Or 22 equals, well, 1 minus 4 is -3, but when you square that, you get 9. So I'm going to write this as 9a minus 5. So if I solve this, I would add 5 to both sides to get 27 equals 9a. If I divide both sides by 9, I'd get that a is 3. So my final equation, once we put 3 back in there for a, would be y equals 3 times x minus 4 squared minus 5. So we go back to this point and plug in our value for a once we find that number. All right, so for number 2, it says find the line of symmetry, the vertex, and y-intercept for that equation. So remember, the line of symmetry is the equation x equals h. Remember, the vertex is a coordinate where we have a value for h and k. Now, the first step, to find out what h is, we have that formula opposite of b over 2a. So in our equation, b is 8, so the opposite of 8 is -8, and our a value is -2, and 2 times -2 is -4. So when I simplify that, I get a positive 2. So my vertex, my h value, which would just be your x coordinate for your vertex, is 2. That also means that your line of symmetry would be the equation x equals 2. All right, now to find our value for k, that just means that we're just going to put whatever h is into the function. So every time I see an x, I'm going to replace it with 2. So it'd be -2 times 2 squared plus 8 times 2 minus 1. And when you go to simplify that, you can just plug it in your calculator if you want, but if you simplify it, you end up getting 7 as your answer. So our vertex will be the coordinate 2, 7. Now, your y-intercept, that's always where x is 0. Now, when it's in standard form, it's going to be the coordinate where x is 0, y is c. So our y-intercept is at -1. So it'll be the coordinate where x is 0, y is -1. All right, so for number 3, we're asked to find the axis of symmetry, the vertex and the y-intercept, and then we need to factor the quadratic, and then we're going to find the x-intercepts. All right, well, let's first start by finding, I don't know why this is doing this. There we go. Let's first start by finding the vertex. So remember, the vertex is at coordinate h and k. So to find h, we do the opposite of b over 2a. So b in this case is -8, so the opposite of -8 is a positive 8. A in this case is 1. Okay, so we would have 1 there. So 2 times 1 would just be 2. So our value for our value for h, 8 divided by 2 is 4. So for our vertex, our x value is 4. Now remember, your axis of symmetry is x in the form x equals h. So now we also know the axis of symmetry would be at x equals 4. So if I want to even put that in my graph here, that would be my line of symmetry. All right, so now let's finish by finding the rest of the vertex. So to find the k value of the vertex, we would just take f of h. So that just means that we're just going to put h into the function. So every time that we see an x, I'm going to replace it with 4. So we would have 4 squared minus 8 times 4 plus 7. And you can just type that in your calculator. When you do that, you get -9 as your answer. So our vertex is going to be the coordinate 4, -9. Let's go ahead and put that on our graph here. The y-intercept. The y-intercept is our c value. So So when we look at this equation that's in standard form, our value for C is this 7. So our y-intercept would be the coordinate where x is 0, y is 7. So let's go ahead and put that on our graph. All right, now technically we have enough here to graph this, because if I want to, I could reflect this y-intercept over this line of symmetry. It's 1, 2, 3, 4 units to the left of the line, so I'm going to put another point, 1, 2, 3, 4 units to the right of the line of symmetry. So if I wanted to, I'd connect those, but since they asked for the x-intercepts, I'll just be a little bit more precise by finding those next. So in order to find the x-intercepts, we need to factor that quadratic. So I'm going to look to see what two numbers multiply together to be 7 that add together to be negative 8. Well, that would be negative 1 and negative 7. Because negative 1 times negative 7 is a positive 7, and negative 1 plus negative 7 is negative 8. And so the x-intercepts would just be the 0. So if I set those equal to 0 and solve them, I would get 1 and 7, or if you write them as coordinates, it'd be 1, 0, and 7, 0. If I write those down so we can graph those. All right, so now we can connect these to create our parabola. There you have it. All right, so for number 4, they just asked us to find the x-intercepts. Now the x-intercepts, we get that every time we have a factor with an x involved. So we're not going to get an x-intercept from that 3. So if this were a multiple choice question and one of the choices were listing out our other values for x, but one of the choices was 3, that would be wrong. So if I set those factors equal to 0 and solve them, we would get that our x-intercepts would be 5 and negative 7. Or we could list them as coordinates. If you list them as coordinates, it would be the coordinate 5, 0, and negative 7, 0. All right, let's look at number 5. It says, write an equation in factored form for quadratic with x-intercepts at 4, 0, and negative 3, 0. Another point at 2, 20. All right, so now for this one, the way that I taught it, a little bit different from the form on the front, but I taught you guys saying that our equation in factored form would be this, where C is our zeros or x-intercepts. So using that, I would use these x-intercepts. So we would have x minus 4. X minus negative 3 would be x plus 3. Now, just like we did on the first problem, we're trying to find out what a is, or we have to find out what a is next, I should say. We're going to use that coordinate that they give us, where x is 2 and y is 20. So I would say 20 equals a times 2 minus 4 times 2 plus 3. Well, 2 minus 4 is, 2 minus 4, that's negative 2. 2 plus 3 is 5. So this would be the same as saying 20 equals negative 10a. So if I divide both sides by negative 10, I would get that a is negative 2. So my equation would be y equals negative 2 times x minus 4 times x plus 3. All right, for the next couple, we're going to solve these using the quadratic formula. So let's look at 6a. So for this one, remember when you use a quadratic formula, you want to get it equal to 0. And in standard form, so now we have it in standard form equal to 0. So we're going to use a quadratic formula. So it'll be x equals opposite of b, so negative 3, plus or minus the square root of b squared, so 9, minus 4 times a, which is 2, times c, which is negative 20. And all of that's divided by 2a, so it'll be 2 times 2. All right, do this in parts. Do not try to do this all at once on your calculator. You want to simplify it under the square root first. So I'm going to take, so what you can do on your calculator is you can type in just 9 minus 4 times 2 times negative 20. When you do that, you get 169. The square root of 169 is 13. So there's going to be two answers, one where we add 13 and one we subtract 13 from negative 3. So if I do negative 3 plus 13, I get, so I'll do this. So I had negative 3 plus 13 is 10. So I'd have 10 fourths, and that reduces to 5 halves. And the other solution, if I take negative 3 minus 13, I'd have negative 16 divided by 4, and that simplifies to be negative 4. So those are my two solutions for x. All right, let's look at letter B. Letter B, it's already set equal to 0, and it's in standard form, so we don't have to do any changes to this. So the first thing I'm going to do is I'm going to put this in the quadratic form. This will be the opposite of b, so negative 12, plus or minus the square root of b squared. Now 12 squared is 144, so that'll be minus 4 times a, which is 9, times c, which is negative 1. And so when I go to simplify that, all over 2a. So when I go to simplify this, I'd have negative 12 plus or minus square root of 180, so you can just do that on your calculator, over 18. Now we always need to simplify under the square root. Okay, so now if you type in the square root of 180, you're going to get a decimal. We want to have the exact answer, so we need to simplify 180, the square root of 180. So you just look for any two numbers that multiply together to be 180. So you could start with 2 and 90. Start with 3 and 60. Even start out with 6 and 30. Or I look at this and I say 10 times 18. It ends in 0, so 10 will work. And just makes it a little bit more balanced if we use a bigger number, but you don't have to. So 10 breaks down to be 2 times 5, and I circle those because 2 and 5 are prime numbers, so it reminds me I'm done with those numbers. 18, I'm going to do 2 times 9, and then 9 breaks down to be 3 times 3. All right, so this is a square root. So the way that a square root works, remember we use that buddy system. We talked about that in class. So for example, at my house, my daughters, if they ever want to leave the house, they have to leave with a buddy, whether it's another sister or the dog or one of us. So we don't want them going for a walk by themselves. So that's the rules for this radical. Now, if it's a cubed root, we would do a buddies of 3. If it's a fourth root, we'd be looking for buddies of 4. Well, here it's a square root, so they just have to go out with a buddy. So I look for pairs of numbers. So I have a pair of 2's, so the 2's get to leave the radical. I see that I have a pair of 3's, so the 3's get to leave the radical. But the 5 doesn't have a buddy, so it stays under the radical. So that's going to simplify to be 6 times the square root of 5. All right, now what I'm going to do is I'm going to look at what's outside of the radical, just the 12, the 6, and the 18. I don't worry about the 5, because that I can't touch. But the 12, 16, and 18, those are all divisible by 6. I want to find the largest number that goes into all of those values. I'm going to divide them all by 6. So negative 12 divided by 6 would be negative 2. Then we'd have 1 square root of 5, or just square root of 5, and 18 divided by 6 would be 3. So that can't be reduced any further, so that would be our answer. All right. Let's end by looking at letter C here. So letter C, we want to get this in standard form and equal to 0. So make sure when you subtract 4x from both sides, make sure you put it in the right spot. So it would go there in the middle. And then we're going to use our quadratic formula. So x equals opposite of b, so opposite of negative 4 is a positive 4. Plus or minus a square root. So again, when you square these, just go ahead and square it in your head. Negative 4, when you square it, it's a positive 16. So that'll be minus 4 times a, which is 1, times c, which is 5. All divided by 2a. A is 1, so just be 2 times 1, it is 2. So for this, when we simplify what's under the radical, we end up getting negative 4. Now remember, we can't take the square root of a negative number, so what I'm going to do is I'm going to factor out an I and make that positive. The square root of 4 is 2, so we'd have 4 plus or minus 2i, all divided by 2. And all of that is divisible by 2, so 4 divided by 2 is 2, so we have 2 plus or minus 1i, or just I, and in our denominator, 2 divided by 2 would be 1. So we just have 2 plus or minus I is your answer. So that's how you do number 6C.